Okay, so now we have another presentation from Shajay. Shajay is, I think, at the moment dealing with a deadline at Zaha Hadid Architects. But for the benefit of the audience, I'll just give a brief introduction. He recorded his presentation. We'll play in a moment. So Shajay Bhooshan is a senior associate at Zaha Hadid Architects, where he co-founded and heads the research activities of the computation and design, so Zaha Code group. He also works as a studio master at the AADRL master's program in London. He pursues his research in structure and fabrication, aware architecture geometry, as a PhD candidate at the Block Research Group at ETH Zurich. And previously, he has worked at Populous London and completed his MPhil from University of Bath and MArch from the AA School of Architecture in London. So I had the opportunity to collaborate with Shajay before when I was working with Zaha Hadid and Patrick Schumacher, and it's a privilege to have his talk here. He has an in-depth understanding of the application of computational design in the industry, and I will play his presentation now.
Good morning. My name is Shajay, and I will talk about a participatory urban future for our cities and neighborhoods, and what might be the associated architectural technology stack. Firstly, I would like to thank Abel for the invitation and the preceding sets of conversations with him, which have been very rewarding for me, and also to Claudia for arranging with the schedule and logistics, etc. So what I'm going to be talking about will be illustrated and exemplified mostly by the work that we're currently doing and have been doing at the Design Research Lab through my studio at the AA, and also some of the related professional work that we have started at with architects. The basic idea or that I want to communicate is that we are combining emerging and rapidly evolving technologies in computer graphics and geometry, along with similar progress being made in robotic fabrication, and also the extraordinary opportunities offered by video game technologies and video game worlds. That these three things could be combined as a solution to this. What do we mean by that? Typically, the built environment, even though it affects all of us, hardly any one of us has a say on when things are built, how they're built, and so on. So as a consequence, they end up being unloved and oftentimes leading to demolition, and which, as we all know, causes quite a lot of carbon emissions and so on. So the 20th century kind of paradigm or obsession with automation and universality, treating buildings as cars and cities as machines, has kind of led to this kind of sprawled city, a very low density development, something that is amenable to the motor car, and not particularly amenable to humans. And on the other hand, it has also kind of made cities like these, in dense human scale urban cities, pedestrian friendly cities, to become fall out of favor. So but reality bears other evidence. In reality, Atlanta consumes order of more magnitude of resources and carbon footprint compared to Barcelona for the same principle. And this is very easy to know why, because sprawl obviously consumes a lot more resources to heat and to commute, and apart from causing a lot of social isolation and mental health issues. So perhaps it's kind of time to think about not privileging automation and universality, but like considering more about material and energy conservation and adaptability and flexibility of our cities and of our architecture. Yeah. So how do we change this? I believe like we have to change at least two things. One of them is, of course, how we design and how we build. And this is where we feel the first two aspects like really come to bear, like geometry and also robots. And one of the things that like really interests us is like how to capture some of these ancient wisdoms in masonry, particularly not only the global shape, like which is particularly suited for very low strength materials like brick and even many cases adobe and so on. But also how to lay the material in specific directions, like which are aligned with the compressive force flow, thereby even offering a further paradigm to use low strength and also less material to span space. And this is also very much compatible with the kind of modern 3D printing logic, even in whether in clay or in cement, because both of these are highly compression dominant materials, and so a lot of the logic of masonry transfers over to robotic 3D printing as well. And some of these principles, when they're applied to even building elements, like not necessarily the entire building, but just building elements, already like are bearing results or showing evidence that this could be quite impactful. So the Block Research Group, for example, is now commercializing this kind of floor slab where the introduction of a kind of compressive logic at the bottom and the rib stiffeners lead to a lot of material savings and also gaining back some of the spatial effects and back into the design of the space. And some of these were recently, some of these principles were also recently demonstrated at a much larger scale in Venice. So here, all the blocks are following the masonry logic. There is no reinforcement. It's entirely held in compression. And also each of the layers within that, within each block is also following a kind of Nubian vaulting logic where like the filaments of concrete extrusion are aligned perfectly orthogonal to the force flow, the compressive force flow. And also you can see that the steel is cleanly separated and from the concrete, so it also allows for easy recycling and so on. So masonry logic is definitely something to consider when we are thinking about 3D printing in concrete and compression dominant materials. So I won't belabor these points, but like the logic does result in through various features of masonry lead to reduction in the overall amount of concrete that we can use, and also 3D printing can allow precise placement of material where it is needed, kind of like an artificial stone which is carved out and mostly hollow. So enormous material savings that way, and also because it's dry assembly, you could disassemble and reuse this, and also replace some of the blocks if they were to be damaged, or so there's a repair regimen that could also be implemented, and also because of the clean separation of materials, it's very easy to recycle or crush the concrete or recycle the steel separately, which is one of the big problems with reinforced concrete is the steel and is deeply embedded within the concrete, and separating them is a bit of an issue. So that's that, like on change one on how do we design and how to be built, like trying to incorporate as much of like the ancient geometric principles of masonry construction, and also like the methods of drawing them and so on. What is change two? Like that is like who decides where and how big and how much these buildings should be, like and that's where we're increasingly paying a lot of attention to video games. Why? Because unlike CAD software and other engineering frameworks, which do not actually represent any of the end user, like games allows us to like truly represent in our software systems like the end user. So this is a huge change. Like as soon as you start thinking about the end user, like the way you design already changes. So and in addition, you games are built for choice. Like everything is about actions and a choice menu. So like which is again like something that comes default with any game. And so that's another reason why we're kind of interested in tapping into and incorporating all of our geometric and robotic manufacturing progress into video game engines. So like we originally started with Unity, but now like we've switched over to Unreal because there's far greater compatibility with our geometry and manufacturing frameworks, code framework. And yeah, so combining this idea that the users are represented and there is lots of choice, there can be a wide variety of alternative outcomes like that we obviously need to consider. And so we're also kind of prototyping real world applications of this. For example, like for a residential development off of an island in Honduras, like we developed this kind of web app where users can choose pixels and also rights related to those pixels, like viewing rights and exclusion rights, and like so it becomes like an asset that like they own, but also once you convert it into a user-owned asset, like then they can also trade and so on. So that's the general idea of like this kind of pixelized version of, and it's also video game compatible. Right? So like that's the tech stack, like material conserving and robotically made building parts and building shapes, and so-called architectural geometry, which has a structural and fabrication awareness. And the second big part is end user participation. And so this together, they kind of really show that like one size need not fit all. Like you can address the various kind of economic and social and cultural categories or requirements of individual users, and spatial requirements and desires and so on. And what it also means that if like the demographic changes, if the end users change, or the relationships between them change, or the professions and work relations change, like or how they use space changes, like like the parameters could be recomputed, and like it could also lead to a completely different language even, like so there's not like a prescription of like a particular style. There's only a prescription of like using these kind of technology and representing users and user choice, and also like the kind of particularly digital fabrication methods to realize these spatial communities. So one version of this, obviously already lots of tech companies tried this. It's a centralized model, like and famous among them is Google, and they tried a version of this like in Toronto, where they came up with a kit of parts and also a set of design that can be composed out of the kit of parts, and also a timber related supply chain to make those parts in a large gigafactory. So So there is the A part, which, you know, it is some form of material conserving shapes or designs, and then there's the digital manufacturing bit, which is so there's a lot of innovation here that like Google and Sidewalk Lab like did achieve and like made progress in several fronts, but there were some issues which particularly pertinent to the current discussion. What are those like? And if in considering if we just switch to a different let's say economy or profession, like consider centralized games, where like a game like Fortnite, like millions and millions of people play Fortnite every month, and they spend inordinate amounts of time and expenses. They make in-game purchases for of assets and you know, so they do spend quite a lot. It's a big economy, but it is a closed one-sided economy. So users just buy stuff, and the developers like develop features that like they think they will sell. So but the issue with this is like you can easily replace, for example, the Fortnite developer with like a famous well-known architectural software developer, for example, and you can replace game users with architects, and we know what the issues with that are like. And in comparison, we can think of like another game like Axie Infinity, where the small change that makes a huge difference. What is that small change? It's that like the users own the assets. And as soon as the users own the assets through a trustless system like a blockchain, there's individual ownership, and that means that they collaborate, users collaborate, create asset pools, and then this leads to an actual multi-sided cyber economy, like people can trade, and so of course there's no real world action being a consequence to these, but there are like people genuinely making a living out of solving these kind of in-game puzzles and so on. So there's like this is a vastly improved model, all just because the assets are owned individually by the users, and it is guaranteed by a trustless system. And some other issue with like the Google centralized model is the fact that like architecture and the built environment is not only a technology driven domain. It's a deeply social cultural phenomena, and or there are very many human aspects to this, human system aspects to it. This kind of then leads to all of the problems that this person is talking about from in the education and healthcare industry. All of this readily applies to the built environment, like things are like inertia around status quo, like there's lots of regulatory inertia, very difficult to change it. It's very varied from one city to another and one country to another. There's like a deep disconnect between users and stakeholders and the investors, and that's like one of the problems that we are trying to solve with this particular technology stack, is bringing the users in. And also there's like a soul cycle, and there's a lot of legacy infrastructure, etc. So all of the things that like are very true for education and healthcare is also true for the AC industry. So that's another issue. And the last issue or critical issue is this disparity between like the so-called SME contributions to the built environment, the economy of the built environment, and the large businesses. So 1% of all the companies, AEC companies in the UK, contribute to 40% of the overall turnover, but the other 99% contributes also a reasonably sizable 60%. And so that means like you cannot have like the same system applied to both sides of this. Like so the centralized model appeals to the right side, like the 1%, like we need something else for the left side. So these are some of the issues that we are trying to tackle with a different text stack, like the one that we propose, a participatory model, where people there's a possibility of asset ownership by individuals, and also representation of end users in the tech. So, and we are not saying it's entirely decentralized. We need like the centralized efficiencies for like supply chain, even computational infrastructure like AWS and all of the high speed computer infrastructure. But like where we can make use of things like blockchains is in decentralized ownership and value. Like, so like the assets are just the registries are decentralized, like but like they're kind of centrally operated. And we are trying this in Honduras with a little test, real world test. Like we started with the idea of two hypothetical companies, one on the early configuration side and the user participation side, like which uses an Unreal game engine, and then the right side to physically realize this, whatever choices that the people make. And so this is one potential future that we imagine by playing the game ourselves. And this is how it works. Like it actually tends to be a lot more work for the design team, because we have to kind of think of various possibilities between which pixels will be picked and what will be the state of the pixel, etc. And also we need to then think of a coherent, like part to whole kind of relationships, and like and keep it varied enough that like it doesn't end up looking like one size fits all anyway. So that ends up to be a lot more and a lot different to kind of design work that then we might normally be used to. So and also there's more work to be done with, like, you know, detailing all the kit, each of the parts and so on. And here's the ideas related to the microfactory. Like, so it's low investment, like you just import the robots and use local labor, some of whom are highly skilled in carpentry, like, so you're augmenting the local economy. And so rather than bring in prefabricated boxes, you try and make them on site or near site. And that also gives us a bit of a in-depth view of like what how to convert raw material into the final outcome. And so this is where we are at, like in terms of implementing it. It is like at the end of Riva stage 3 now, and here's like the latest or one of the latest versions of the so-called configurator, which allows for some choice. Of course, this is not like the end goal, like it is like just the beginning. Like once we put the idea, we're building up the framework, and also like the intellectual thinking behind like how to legally encode all of these pixels, and you know, what do people want, etc. Like, so it's just the beginning, like, but like the idea is to kind of decentralize the ownership of these pixels. And one of the other difficulties is that like the pixels become related structurally. It's not that like they're individually independent pixels that can be tackled independently. So there's like all of sub relations that are, some of which are structural, some are fire compartmentalizing, and so on. Like, so there are quite a few fallouts from just trying to approach it in this way, like who pays for the electricity and how much and so on. And so it's been a very interesting journey so far, and like we believe like that this could lead to something more substantial than the 11 or 12 houses that we're going to build next year. And hopefully we can kind of demonstrate the value of thinking in a participatory way, through a real world example. And in doing so, like, we hope to realize at least some of the manifesto that the Eameses famously set out for their in their case study houses, like how to understand a vocabulary of materials and techniques, aka geometry and robotic manufacturing and the associated tectonic, and also users and a system of mass production, and so on. So thank you very much for your attention, and I will join you for the panel discussion shortly.